All right, welcome back to this series of videos from my book, The Effect, available for free on theeffectbook.net or for purchase. You can also find links there. In this video, we're going to be talking about the relationships between variables and how we can describe those relationships. You can imagine why that might be important if we're talking about causal inference, because really what we're trying to do, if we're trying to look at the effect of one variable on another, is we are looking at the relationship between those two variables and then trying to figure out whether that relationship is indeed causal, or what part of that relationship is causal. We'll get there. But for now, all we're going to try to do is describe how two variables are related to each other, not worrying about the causality of that relationship, just describing that relationship. And we're going to do a few videos on that. So a lot of this really just continues on from what we talked about in the last set of videos about describing variables. In those sets of videos, we talked about the distributions of variables, how we can describe the distribution of a variable. If it's categorical, we just look at the simple proportion of observations in each category, and that's pretty much all there is to it. With a continuous variable, we can describe the density distribution of that variable, and that will show us all the different percentiles, all the different things we can describe, and then we can summarize it further with averages and medians and etc. But how do we use that information to look at the relationship between two variables? And it turns out to be pretty straightforward if you think about it, continuing in that way of looking at distributions, because all we're doing when we are looking at the relationship between two variables is looking at what's called a conditional distribution. Now, in statistics, what conditioning means is holding one thing constant, looking at a particular value of one variable. What do you get for something else? What does the distribution look like for something else? Let me give you an example. So let's say you're looking at the distribution of sex, of babies. So like, are they boys or girls, right? Maybe it's 50-50, right? So the distribution of that categorical variable is 50%, 50%. Okay, great. Now, let's say that you learn that you meet somebody, you know that you're going to meet somebody. You're going to meet some random person you never met before. You don't know their sex, but somebody tells you, oh yes, this person's name is Sarah, right? So before you heard that information, right, before you knew that their name was Sarah, your best guess that you could possibly make about what their sex was going to be would be 50% male, 50% female, right? But learning that information is probably going to shift that distribution, right? It's probably going to go from 50%, 50% to like pretty strongly favor of female. Not 100% maybe, but pretty strongly, right? Maybe it's 95% female, 5% male. I don't know, something like that, right? So what is this saying? Conditional on somebody's name being Sarah, the probability that they are female is roughly 95%, right? Or even higher, perhaps. I don't know. But it's not 50-50. Right? Learning one piece of information change your distribution of a different variable. That is what it means for two variables to be related to each other. Learning something about one variable tells you something about the distribution of another. Contrast this to variables that are independent of each other, that are not related to each other. So for example, if I roll a die and I learn that, I know before I roll the die that I have a 1/6 chance of getting 1, 2, 3, 4, 5, or 6 if it's a 6-sided die. Now let's say that I roll the die and I observe that I have rolled a 1. What does that tell me? How does that change the distribution of the next roll of the die? It doesn't, right? It's still 1/6 chance to get 1, 2, 3, 4, 5, or 6. If learning the value of something tells you nothing, changes nothing about the distribution of another variable, then those two things are independent of each other. But when they're dependent, then conditional on one value, conditional on learning something, can change our distribution of the other. So all that we're doing when we're describing the relationship between variables is describing how the distribution of one variable changes as we look at different conditional values of the other, right? So are name and sex related to each other? Yes, because if I tell you that somebody's name is Sarah, that gives you one distribution of sex. If I tell you that somebody's name is Chris, that gives you a different distribution of sex, right? So, and that's telling you how those two variables might be related to each other. We can do the exact same thing when we are describing distributions. We talked in previous videos about how we can describe and summarize distributions. Maybe I can look at a distribution of a continuous variable and take the average of it, or take them. I can take the mean, I can take the median, right? That is a way of summarizing that variable. If that average changes for different values of another variable, then those two variables are related to each other, and I am describing that relationship to you. Let's take as an example here vitamin E. So I just got some data here on whether people happen to take vitamin E as a supplement. Vitamin E is a supplement that didn't used to be recommended, then it was recommended by health professionals for a short while, and then it was no longer recommended again. All right. So we might be curious about how taking vitamin E relates to other kinds of health behaviors, perhaps, right? You might expect, especially during the time that it was being recommended, that people who are healthy for other reasons, who decide to follow the health recommendations a lot, are going to choose to start taking vitamin E, even when they might not take it other times because it's not being recommended, right? So it's going to look like vitamin E is related to a lot of healthy stuff when it's really just that healthy people choose to take it, right? This is the basis of a study by Emily Oster on this particular topic. But in any way, let's use this to look at conditional distributions. So let's start by just looking at the proportion of people who take vitamin E, right? Do people take vitamin E or not? And it looks like in the data, about 15% of people take vitamin E. Okay, great. But let's now look at that same distribution. About 15% take it, about 85% don't. Conditional on the value of another variable. Let's look at whether you are smoking or not. So here's a graph that shows the conditional distribution of taking vitamin E, conditional on smoking or not smoking. Among smokers, the proportion who take vitamin E is lower than it is among people who do not smoke, right? I'm describing to you how the distribution of vitamin E taking changes when you select on different values of smoking. That is what a conditional distribution is. On the left here, we have the distribution of vitamin E taking conditional on not smoking. On the right, we have the distribution of vitamin E taking conditional on smoking. And look, because of the fact that you can tell that these two distributions are different, we would say that vitamin E taking, the choice to take vitamin E, is related to the choice to smoke or not. At this point, we don't know whether one of those things causes the other or what the causal relationship is here at all. We just know that statistically, these two things are related to each other. So that's an example for a categorical variable. We can see how the categorical distribution changes for different values of the variable, but I can do the exact same thing for a continuous variable. I can look at how the density distribution changes conditional on different variables that I might look at. So here I'm going to look at how much vitamin E you took, which is a continuous variable, as opposed to not just whether you took it or not, but how much you took, and conditional on whether you exercised vigorously in the last month. And so here we can see that, again, the distribution does change a little bit. The density either shifts a little bit left, shifts a little bit right, conditional on whether you exercised vigorously last month. The fact that learning whether you exercised vigorously changes the distribution that I would look at for your vitamin E taking tells me that one of those things is conditional on the other. So once we have this idea of conditional distributions, that we have the exact same idea about looking at a distribution of a variable conditional on values of another variable, then we've suddenly got the entire thing. The entire thing is in the bag, right? And a lot of what we're going to be doing when we're doing causal inference is looking at conditional means. This is just the idea that we can take that exact same thing that we had before. We have this distribution. We want to get the central tendency of that distribution. So I'm going to summarize my distribution using, let's say, the mean. And I'm going to just expand that to the fact that we have conditional distributions. Now, instead of one distribution, I have multiple. And so I might look at the mean for this distribution and the mean for that distribution and see if they are different. And this would let me do something like say, hey, is the average amount of vitamin E that you take different depending on whether you exercise vigorously or not? These are conditional means. And I can look at the conditional, any sort of summary statistic for my distribution. I can look at the conditional mean. Yeah, I can also look at the conditional median or the conditional standard deviation or the conditional skew or the conditional interquartile range or whatever it is, right? I'm describing how the distributions are different because I know how to describe a distribution conditional on some other variable. And in doing so, I'm describing how the one variable changes over different values of another. So most commonly, this is conditional means. So in the case of a categorical variable, I might say, okay, the mean number of people who take vitamin E is something like 10% among smokers and something like 20% among non-smokers. I'm describing how the conditional mean of vitamin E taking changes over the different values of smoking or not. Or I might describe how the mean of vitamin E amount that you're taking changes over different levels of vigorous exercise. This is a way of describing how the conditional mean changes. Things get a little bit more complex when you're conditioning on a continuous variable. So in this case, again, I can't just condition on you taking exactly 0.1376 grams of vitamin E because there's probably only one person who does that, if anybody. So here it gets a little bit more complex, but there are things that we can do as well. Just like before, we can bin up that continuous variable. Instead of looking at all the values, I can put it in the bins and I can say, hey, what's the conditional mean of one variable within all these other variables? So I might, for example, take what's the proportion of people who take vitamin E within different bins of body mass index. That's something that I can do. And in fact, here I have done it. Here's a table that shows for different bins of what your BMI might be, what proportion of people take vitamin E within those bins. And of course, the proportion is just the mean of a binary variable. I can take that exact same table, I can graph it out to show you how the conditional mean, which you can see on the y-axis there, is changing as we move along the x-axis. Now, this bin approach is a little iffy, right? It's a little arbitrary picking those bins. And so there are going to be a lot of other ways that we can describe these sorts of conditional means or these relationships when we have continuous variables. We'll talk a little bit about that next time when we talk about line fitting. All right, that is it for this video. I will see you next time. Thank you.